Hello and welcome back. Today we're going to be doing logarithmic functions as inverses. So we're going to take logarithmic and exponential functions and show how they are inverses of one another, and we're going to do some solving with that. So our essential question is, how are logarithmic functions related to exponential functions? Hint, hint, by the title, you can assume. Our lesson objective is to write, evaluate, and graph logarithmic expressions and functions. Are you ready? Here we go. Okay, so let me tell you about logarithms first. A logarithm base b of a positive number x satisfies the following definition. For b greater than 0 and not equal to 1, log base b of x equals y if and only if b to the power of y equals x. So we can interchange these formulas. So log base b of x equals y and b to the power of y equals x. In other words, the logarithm y is the exponent to which b must be raised to get x. So a common logarithm is a logarithm with base 10. You can write these as log base 10 of x, or just simply write it as log of x, because we assume that it's base 10 unless it's, in some other base. Base 10 is what we use like all the time in math, except for, examples like time. Then we use base 60 or base 24. When you use a logarithm of a quantity instead of the quantity, you are using a logarithmic scale. The Richter scale is an example of this and gives us the measurements of an earthquake's magnitude. So we're going to do a couple of those. A logarithmic function is the inverse of an exponential function. So y equals 10 to the power of x and y equals log of x. So that's the logarithmic function. Alright, so we're going to be writing exponential functions in logarithmic form to start with. So what is the logarithmic form of each equation? So I have 100 equals 10 squared. Is that true? Does 100 equal 10 squared? Yes, it does. So since it is true, we can rewrite this in logarithmic form. Now, do you remember from the vocab, I said b to the power of y equals x. So log base b of x equals y. So we can rewrite this as log base 10 of 100 equals 2. So what power do we need to raise our base to in order to get that number 100? This is how we rewrite it in logarithmic form. Log base 10 of 100 equals 2. What about this one? 81 equals 3 to the 4th power. Well, let's start by figuring out what is our base. So what is our b? Our b is a number that's being raised to a power, so that's 3. So log base 3 of what number are we looking for? Well, that's 81 equals, what power did we raise that to? 4. So log base 3 of 81 equals 4. This one, 36 equals 6 squared. Log base 6 of 36 equals 2. You getting it? Okay, this one, 8 over 27 equals 2/3 to the 3rd power. So same rules apply. Log of 2/3, or log base 2/3 of 8 over 27 equals 3. Pretty simple, right? Alright, evaluating a logarithm. Multiple choice. What is the value of log base 8 32? So, any thoughts? Let's start by just seeing what the value is. We're going to set that equal to x because it's some unknown value that we don't know. Log base 8 of 32 equals x. Since it's a logarithmic function, can we rewrite it as an exponential function? Yes. So use your b to the y equals x and rewrite it as 32 equals 8 to the power of x. So what, how can we rewrite 8 so that the power of 8 is the same as the power of 32? Well, do 8 and 32 have a number in common? Like a base in common? They would have 2 in common. 2 to the 5th is 32, and 2 to the third is 8. So we can rewrite this as 2 to the fifth equals 2 to the third times x. We can just multiply that 3x together, and then we can just go ahead and solve just those exponents and say 5 equals 3x. Well, to find what x is, you divide by 3, so the correct answer is 5/3. See how that works? It's pretty cool. Okay, so I want you to go ahead and do a couple of these. I'll do the first one with you. Remember, our first thing when we solve, we want to set it equal to x. Okay, then I need to rewrite this. 5 to the power of x equals 125. Well, I know that 5 and 125 are powers of 5. So I have 5 to the first power times x. Do you know what 5 to what power makes 125? I believe it is 3. Yes. 5 to the third power. Since these are both in base 5, I can just say x equals 3. So that's the value of the logarithm. Why don't you go ahead and do these two, and I'll be with you in just a moment. Pause your video. Alright, I went ahead and set up both of these equations. So I have 4 to the x equals 32, and 64 to the x equals 1 over 32. So now we're going to use our properties of exponents to go ahead and get these in the same form. So between 4 and 32, is 32 a power? Can I have a power of 4 that makes 32? No, I can't. But what about 2? I have 2 to the 2x, that makes 4 to the x power, equals 2, is it to the fifth power, is 32? Yes. So then I can set these equal to each other. 2x equals 5, x equals 5/2. So there's the answer to that one. This last one is a little more tricky because we have to use different properties of exponents. So what I'm going to need to do is I need to rewrite these also as powers of 2. So this is 2 to the 6x power. Now, do you remember about negative exponents? Turning them into fractions? What if this was just regular 32? Well, that's 2 to the fifth power, which we saw over here. So to make that a fraction, it's 2 to the negative fifth power. That's what makes it 1 over 32. And set these equal to each other. X equals negative 5/6 is the answer to that one. Alright, moving right along. In December 2004, an earthquake with a magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra. Another earthquake hit in March 2005 with a magnitude of 8.7. So everybody know how the Richter scale works? It's on a 10-point scale, 0 being no activity, and then 10 being like ultimate destruction, basically. So the formula log of I1 over I2 equals M minus M2 compares the intensity levels of the earthquakes, where I is the intensity level determined by the seismograph, and M is the magnitude on the Richter scale. So how many times more intense was the December earthquake than the March earthquake? So we need to figure out what's that difference. Okay, so let's go ahead and look at our two magnitudes. So our first magnitude that was higher was 9.3, and the second one's 8.7. So let's go ahead and plug those in. Log of I1 over I2 equals 9.2 minus 8.7. That's supposed to be 9.2. So we get, if you subtract those, that's 0.6. Okay, so now we have log of two numbers that we're dividing equals a number. Okay, so in order to rewrite those, remember if there's no log, it's assumed that our log is 10. So 10 to the 0.6 power equals I1 over I2, and 10 to the 0.6 power is about 4. So it was 4 times greater. The power of the one earthquake was 4 times greater, even though it was only a little less than half a point higher on the Richter scale. It was 4 times greater, more intense. So you can, kind of gives you an idea of how the Richter scale numbering works. Alright, here are our families of logarithmic functions. So our parent function is y equals log base b of x. If we have a stretch, is where a is greater than 1. A compression is where a is between 0 and 1. And a reflection is where a is negative. So, nothing new. So, horizontal translations, still h. Vertical translations, still k. Put them all together, you get y equals a log base b of x minus h plus k. If these parent functions don't look familiar to you by now, you might want to wake up and retake the class. Okay, so translating. How does the graph of y equals log base b of x minus 3 plus 4 compare to the parent function? Well, the parent function would be y equals log base b of x. So minus 3 is going to be our horizontal translation, still opposite, goes to the right. Plus 4 goes up. Alright, so we have to look at our domains and our ranges. So we have an asymptote. Instead of being x equals 0, is now x equals 3, because it's gone to the right 3. Range is still all real numbers. Alright, here we go. I want you to describe the translation of these functions from the parent function. This is what you're going to discuss with your partner. And your homework is to do 7-3 and the practice quiz. We will do the second half of class because we have a block class tomorrow. Alright, that's all. Have a good night.